We continue our lesson with the next subtopic, which is IR, infrared absorption, spectroscopy, another subtopic, the last subtopic, inshallah, in chapter 2. Okay, so let's look at the content of the this subtopic. Okay, first saya buatkan sikit lah dekat sini dia punya outline for this chapter. Okay, similar to UV, for IR, we will look at for FTIR. Okay, FTIR, we will look at the principle of the molecule that can absorb UV IR. Okay, principle of molecule. Then principle. First, types of molecule. Second, vibration mode. Vibration mode. Okay. Principle is these two types of molecule, as well as vibration modes or vibration types. Yeah. Okay. Then we will look at the sample prep. Yeah. In UV, we don't have sample prep because sample prep is preparing standard solution. Not like IR. IR, we don't have to prepare standard solution, but we need to prepare sample. Okay. Sample prep, it can be gas, it can be liquid, and it can be solid. Okay, and the last one is the application, which is called interpretation. Okay, which is called interpret IR spectra or spectrum. Okay. So these are the outline for chapter for subtopic 2.4. Okay. As an introduction for the principle, IR spectroscopy deal with the interaction of IR radiation with matter. Matter is actually molecule. Okay. IR is also another what we call method, analysis, analytical method for molecule as well. Okay. Mostly for qualitative analysis, not like UV. UV can perform both qualitative and quantitative, but IR is basically for qualitative. It can be done for quantitative, but it is a bit very, very minimum application. Okay. Absorption spectra is recorded as a transmittance. Okay, dia punya spectra nanti tu adalah transmittance versus wave number. Okay. Absorption of the IR arise from the molecular vibrational transition. Okay. The absorption of the infrared radiation by the sample is due to the molecular vibrational transition. Absorption for every substance are at specific wavelength, where IR spectra provide more specific qualitative information. Okay. IR spectra is called a fingerprint because no chemical species will have similar IR spectrum. Tak adalah. So tu kita panggil fingerprint kan. It was like our fingerprint. There is no two person can have same fingerprint. Okay, so the same is the chemical species. There is no two chemical species that have similar IR spectrum, and IR spectrum provide information about chemical nature and the structure of the molecule. From the IR spectrum, we can get the information about types of molecule and also structure of the molecule. Okay, types of the functional group actually. Okay, so this is the spectrum for IR. Yeah, it is the plot of transmitted or percent transmitted versus with number. Okay. Okay, yeah. It is not very useful using absorbance in IR because you can see these two spectrum, yeah, A and B. A has more peak compared to B, so it is more informative. Ya, kalau tak banyak peak ni kita tak tahu nak interpret apa. Tapi kalau banyak peak ni, yes, it is very significant or can give us many information about the compound. Okay, this one saya kita dah pernah tengok dah kan. Types of what we call types of interaction that can happen or types of effect that can happen to the molecule when absorbed in the electromagnetic region. Okay, start dengan radio, microwave just rotation, infrared just vibration, UV cause electronic transition, X-ray cause bond breaking. Okay, and so on and so forth. Yeah. This slide shows the but it is not very informative for us because there is another things first that you need to know. Yeah? For molecule, sekejap. Okay, this one dulu ya, nanti baru saya naik atas. Okay. When IR absorption occur, or in other words, what molecule can absorb IR? Okay, ini dua benda lah. Kalau kita tengok balik dekat outline tadi, principle that discuss what are characteristic or what types of molecule that can absorb IR. In UV, we have looked at the types of molecule, yeah, 3 types of molecule that can absorb UV. But now in IR, absorption can occur when IR radiation interact with molecule that undergoes change in dipole moment when the molecule vibrate or rotates. Okay, we know that the molecule can vibrate or can rotate. Okay, dia bergerak ke sini. As long as it's rotate or vibrate, it can it can change the dipole moment. Okay, for example, in H and Cl. Okay, when it's vibrate or rotate, more electron are in Cl. Okay, when there is a lot electron in the Cl part, it will create a dipole. Okay, means that it is not symmetry. Yeah, okay, more electron will be in the chlorine part. Ya, kalau kamu tengok dalam textbook tu kan biasanya dia lukis bentuk macam ni kecil, ni besar, yang ini merah sikit, yang ini biru. Okay, merah represent electron. Ya. Infrared absorption only occur when the incoming IR photon has sufficient energy for the transition for the next allowed vibrational state. Ya. Samalah dalam any transition, when energy is enough for the allowed for the allowed transition happen, okay, then baru dia akan absorb. Yeah. So for this one saya tak berapa boleh nak explain guna diagram ni ya. Okay. This one lah dia tunjuk ni dua molekul ni kan. Yang ini maksudnya dia expand ya, dia expand. Bond ni makin jadi panjang. Okay. Nampak dia expand ya. So when it expand, it's actually absorb energy ya. So bila dia absorb energy, dia boleh expand, and bila dia expand, if there is a net change of dipole, maksudnya sebelah sini delta negatif, sebelah sini delta positif, then dia boleh absorb IR. Okay. No, sorry. Ya, dua-dua absorb IR, tapi kita boleh observe. Ya. Okay. Okay, this is IR region subdivide into 3 region ya. Kita ada near IR, kita ada mid IR, kita ada far IR. Okay, but the most frequently used for IR spectroscopy is the near IR region, nearest to the visible UV visible, between sorry, this is too big. Sorry, not this one. This one. Yeah, mid IR region, not near IR region. Mid IR region. Okay. For IR pun is not very useful. Okay, sebab sikit je. Yang ni lah paling besar. Yang ni terlalu besar. Okay, yang ni lah. Yang paling banyak adalah between 600 or 800 to 4000. Okay. Nanti kita akan tengok kita punya IR spectrum. Basically in this region. Okay. Okay. So what happen when molecule absorb IR radiation? Kita cakap tadi, bila dia absorb, dia akan vibrate, sama ada bond dia memanjang atau dia okay. Kita panggil bending ya, stretching or bending ya. The energy absorbed will increase the amplitude of the vibrational motion of the bond in the molecule, yeah? But not all bonds in the molecule are capable of absorbing IR energy. Only those bonds that have change in dipole moment are able to absorb IR. Okay, so dia punya keyword for molecule that can absorb IR region is molecule that have change in dipole moment when it's vibrate, can absorb IR radiation. Okay, so this is the keyword, molecule that have changes in dipole moment. Okay. So symmetric bonds such as H2Cl2, ya, sebab dia tak akan jadi delta Z negatif delta positif, dia tak akan absorb IR. Yeah. The larger the dipole change, the stronger the intensity of the band in IR spectrum. Okay. Lagi banyak dia punya dipole, maksudnya macam contoh kalau C dengan C, kita tak nampak sangat bond dia ya. Lagi-lagi kalau C ni simetri, lagi tak nampak lah ya. Tapi kalau besar lah, lagi besar peak dia. Okay. So this is example of dipole moment ya. Kalau OCO disimetri kan, there will be no overall dipole changes ya. Okay. Kalau yang ini, yes, yang ini boleh ada, yang water boleh ada sebab dia, okay, dekat sini dia ada lagi lone pair electron kan, so dia akan ada dipole moment. Okay. Sebenarnya untuk yang ini, kalau kita tengok dalam bentuk animation, dia akan lebih mudah untuk kita faham ya. Tapi since guna iPad ni, saya tak boleh lah nak tunjuk yang software yang saya selalu tunjuk tu ya. Okay. Bila when molecular vibration happen, there is two types of movement, yeah, movement of the bond as well as the atom. Okay, for example, we have stretching. Stretching is when bond length change, okay, ataupun it cause changes of bond length. But for bending, cause changing of bond angle. Okay, bond angle. For example kan, kalau macam saya cuba lukiskan macam ni, kita ada O kat situ. Okay, so bond ni dia masuk ke dalam, keluar, ya. So dia punya angle ni akan mengecil dan membesar semula. Tapi kalau bond length ni macam ni contohnya, dia stretching. Stretching tu dia tertariklah ke kanan dan ke kiri, sekejap panjang, sekejap pendek, ya. So that is the difference between stretching and bending. So nanti yang ini nanti saya akan tunjukkan video tu lah. Okay. Okay, nanti saya akan tunjukkan. Okay, so for stretching tak banyak, kita ada symmetric stretching dengan asymmetric stretching. Okay, tapi for bending ni ada macam-macam lah. Bending ni kamu bayangkan scissoring kan, kalau kita gunting tu kan, angle gunting tu akan terbuka dan tertutup kan. Okay, bila kita gunting kan, so angle ni the movement is called scissoring because it was like kita buka tutup gunting kan. The second one we have rocking, then we have a twisting, wagging, ya. Yang ini memang susah saya nak tunjuk, nanti kita akan tengok dalam video tu. Okay, cuma kamu cubalah ingat sikit types of stretching dengan bending ni, ya. Kalau dia tanya, ya, kita ada scissoring, rocking, twisting, wagging. InsyaAllah kalau kamu tengok gambar dia nanti, animation dia nanti, mesti kamu akan lebih mudah faham, ya. Okay, yang ni pula symmetric stretching dengan anti-symmetric stretching, ya. Yang ini bond stretching dia, kalau yang ni terkeluar, dia keluar, memanjang, sama-sama memanjang. Okay, tapi kalau yang ni tak, yang ini memanjang, yang ini memendek. Okay, so this is called symmetric, this is called asymmetric or anti-symmetric. Ni bending. Bending ada scissoring, yang ini dua-dua tertutup ke dalam. Rocking dia yang ni ke sini, ni ke sini, ya. Kamu cubalah bayangkan, ya. Tak apa, nanti saya cubakan bagi video tu. Okay, so that is principle of the IR. First about the molecule, and the second about the movement of the, or about the what happened when the molecule absorb IR, ya. What happened to the molecule? Dia akan vibrate lah, either stretching or bending. Okay, now we look at the sample prep, ya. Kita dah tengok dah tadi. Sample prep ada for 3 types, ya. Kita ada gas, kita ada liquid, and kita ada solid. Okay, so yang ini for liquid, sekejap, ya. Okay, for liquid, ya. Yes, try to imagine, not to memorize the word, ya. For liquid, we use KBR. A drop of a pure or neat liquid is squeezed between 2 salt split, ya. Salt split ni dia macam apa dah yang kamu salt split tu dia macam disk lah, ya. 2 disk. Okay, kita dropkan solution tu dekat atas satu disk, ambil another disk, tutupkan kat atas ni, ya. Kita macam buat sandwich lah, ya. Okay, kemudian kita letakkan dekat instrumen. Okay, sandarkan dia kan. InsyaAllah dia tak akan tumpah lah. So that is for liquid sample. Yeah. Okay. For this subtopic, this is quite common concept that you need to know. What is neat liquid? Yeah, neat liquid is a pure liquid that do not contain any solvent or water. Okay, tunggu sekejap ya. Okay, this is the concept that you need to understand in this subtopic preparation of liquid sample. Yeah, neat liquid. Yeah, neat liquid. What does it mean by neat? Yeah, neat liquid means it is a pure liquid. For example, kita tak campur dengan air ataupun tak campur dengan apa-apa solvent. Yeah, macam contoh madu. Madu is considered as a neat liquid. Because it is only a honey, unless if we mix with water, that will become solution. Yeah, so that is neat liquid. Another example of neat liquid. Okay, kalau kamu ambil ethanol semata-mata, 100% ethanol atau whatever lah, ethanol, methanol, ya, without water. That is called neat liquid. Okay. Okay. So, okay. Tak ada apalah. Ini je lah ya. This is just extra information about analyzing liquid sample using this method. Okay. It says that first idea or first point, this method is applied when amount of liquid is small or when suitable solvent is not available. Ya, kalau kita tak ada solvent yang sesuai untuk dissolvekan dia, so kita guna method ni. The second point, a spectrum that determined using this method is called neat spectrum. Okay. And the third one, organic compound that being analysed using this method must be free of water. Ya, sebab tu dia kata tadi neat liquid, tak ada solvent. Not only water, including solvent. Ya, solvent can be organic solvent lah, macam contoh hexane ke. Ya, okay. The second sample preparation is for solid. Ya, tadi for liquid, now solid. Okay. We have 3 common method to analyze solid sample. First, using KBR pellet method. Second, using Nujul-Mal method. And the third one, using organic compound sample in solvent. Okay, kita tengok satu-satu. KBR pellet, this is the one yang saya tunjuk masa dekat lab tu kan, yang kita kena grind kan. Okay, first kita kena grind kan kita punya sample mix dengan KBR. Okay, remember 99 to 1 ratio. Okay, 99 KBR, satu ni sample kita. Then the mixture is ground until you get a fine powder, not a granule. Okay, then we put in a die set. Okay, kita letak dalam dia punya mold ataupun dia punya acuan tu, and press under high pressure. That's all. So kita akan dapat dia punya. Cuma dia punya disadvantage, KBR ni dia senang absorb water. Okay, so dia akan interfere dengan kita punya spectrum. The second method is called Nujul-Mal method. Okay, dia punya proses sama juga. First, kita grind sampel kita. Okay, grind first. Kemudian mix with mineral oil. Mix with mineral oil. Okay, this is 2. Mix with mineral oil. This mineral oil is known as Nujul. That's why we get the names Nujul-Mal method. Okay, we mix the sample with our mineral oil to create a suspension of finely round sample in a mineral oil and then put between salt split. Then bila dia dah campur dengan minyak tadi, dia dah jadi macam liquid kan. Bila liquid, balik semula method yang liquid ni tadi. Okay, sama juga. And the third one is organic compound in a solvent. This is also the same dengan yang tadi. Kita akan balik guna dia macam liquid, because if you have a solid sample that can dissolve in any organic solvent, okay, in any suitable organic solvent, then we mix with the solvent to get solution, and we analyze using liquid method. Place between 2 salt split. Tadi tu kan, letakkan 2 salt split kat tengah-tengah. Yalah, letak dulu atas tu, kemudian letakkan lagi another the second salt split. Dia akan jadi macam sandwich macam tu. Kat tengah-tengah ni ada liquid, ya. So kamu boleh analyze. Okay. Okay, kat sini dia tunjuk ya, KBR pellet method. Okay, first you grind, then masukkan dalam mold dia. Okay, this is grind with KBR. Okay, grind plus KBR. Yeah, grind sample plus KBR. Sorry, with ratio 9 to 1 lah. Yeah, tapi sebenarnya 9 to 1 pun banyak juga. Then place in a mold atau mold, mold. Then press using high pressure. Kita akan dapat this KBR pellet. Okay, then we get KBR pellet. Okay, Nujul-Mal method pun dia tunjuk juga. Okay, macam ni lah jadinya minyak tu very sticky ya. Then bila dah dapat macam tu, kamu letak juga dekat salt split ni, jadilah macam yang liquid tadi. Okay, so this is the IR. This is the IR spectra. Yeah, this is example of IR spectra. Plot of transmittance versus wave number. Okay, plot of transmittance versus wave number. Okay, so I will continue the interpretation for each functional group in the next video. Okay, Assalamualaikum.